Hello everyone, I am Deeksha and today we will be discussing about the probability theorem in mathematics. Contents of today's video: Introduction to probability theory, basic concepts of probability, sample space and events, probability of an event, complementary events, union of events, intersection of events, conditional probability, independent events, addition rules for probability, multiplication rules for probability, law of total probability, Bayes theorem, expected value, and then we conclude. Introduction to probability theory. Probability theory is a branch of mathematics that deals with the study of uncertainty and random events. It provides a framework for analyzing and quantifying the likelihood of different outcomes. Probability theory is widely used in various fields including statistics, economics, engineering, and finance. Basic concepts of probability. Probability is a number between 0 and 1 that represents the likelihood of an event occurring. An event can be a single outcome or a collection of outcomes. The sum of probabilities of all possible outcomes in a sample space is always 1. Sample space and events. The sample space is the set of all possible outcomes of an experiment. An event is a subset of the sample space which represents a particular outcome or a collection of outcomes. Events can be classified as simple events or compound events. Here, simple events meaning single outcomes and compound events meaning collections of outcomes. Probability of an event. The probability of an event A, denoted as P of A, is the likelihood of event A occurring. Probability ranges from 0 to 1, 0 indicating impossibility and 1 indicating certainty. The probability of an event is calculated by dividing the number of favorable outcomes by the total number of possible outcomes. Here is an example. What is the probability of spinning blue? Here we have 8 possible outcomes and 3 are our favorable outcomes. So the probability of spinning blue is 3 by 8. Complementary events. The complement of an event A, denoted as A dash, represents all outcomes that are not in event A. The probability of the complement of an event A is equal to 1 minus the probability of event A. That is, P of A dash is equals to 1 minus P of A. Union of events. The union of two events A and B, denoted as A union B, represents the outcomes that belong to either event A or event B or both. The probability of the union of two events is calculated by adding their individual probabilities and subtracting the probability of their intersection. That is, P of A union B is equals to P of A plus P of B minus P of A intersection B. Intersection of events. Intersection of two events A and B, denoted as A intersection B, represents the outcomes that belong to both event A and event B. The probability of the intersection of two events is calculated by multiplying their individual probabilities. Conditional probability. Conditional probability measures the likelihood of an event A occurring given that event B has already occurred. It is denoted as P A bar B and calculated as probability of the intersection of A and B divided by the probability of event B. Independent events. Two events A and B are independent if the occurrence of one event does not affect the probability of the other event. For independent events, the probability of the intersection of A and B is equal to the product of their individual probabilities. Addition rules for probability. The addition rule for mutually exclusive events states that the probability of the union of two mutually exclusive events is the sum of their individual probabilities. For mutually exclusive events, P of A intersection B is equals to 0 and P of A union B is equals to P of A plus P of B. Multiplication rules for probability. The multiplication rule for independent events states that the probability of the intersection of two independent events is the product of their individual probabilities. For independent events, P of A intersection B is equals to P of A into P of B. Law of total probability. The law of total probability states that the probability of an event A can be calculated by summing the probabilities of A given different mutually exclusive and exhaustive events B1, B2, B3 and so on. Bayes theorem. Bayes theorem is a fundamental concept in probability theory that allows us to update our beliefs about an event based on new evidence. It relates the conditional probability of an event A given event B to the conditional probability of event B given event A. Expected value. The expected value of a random variable is the long-term average value of that variable. It is calculated by multiplying each possible outcome by its probability and summing these products. The expected value provides information about the average outcome or the center of the probability distribution. Conclusion. Probability theory is a powerful tool for analyzing uncertainty and random events. It provides a systematic framework for quantifying the likelihood of different outcomes. Understanding the concepts of probability theory is essential for making informed decisions and solving problems in various fields. Thank you.